In April 2019, the Event Horizon Telescope imaged a shadow 40 billion kilometers in diameter at the center of galaxy M87. The shadow boundary matched the predicted Schwarzschild radius from a 1916 equation Einstein dismissed as physically impossible. The deviation from theoretical prediction was 4.3%. Einstein had spent 2 decades attempting to prove this radius could not exist in nature. November 1915. Einstein publishes field equations describing spacetime curvature. Within 6 weeks, Karl Schwarzschild derives an exact solution while deployed on the Russian front. The solution predicts a critical radius where escape velocity equals light speed. The formula is 2 times the gravitational constant times the mass, divided by the speed of light squared. At this boundary, all future light cones tilt inward. Einstein's documented response, January 9, 1916. The singularity is not a physical reality. The mathematical structure contains no physical mechanism to prevent collapse. A stellar core exceeding 2.5 solar masses exhausts all fusion fuel. Electron degeneracy pressure fails. Neutron degeneracy pressure fails. The core exceeds the Schwarzschild radius. The event horizon forms. All inward trajectories now terminate at the central coordinate singularity. General relativity provides no prediction beyond this point. Einstein interprets this as evidence the equations are incomplete, not evidence the object is real. The Araby 150 rocket detects X-ray source Cygnus X1. Optical analysis identifies blue supergiant. HDE 226,868, mass 30 solar masses, orbiting an invisible companion every 5.6 days. Orbital mechanics constrain the companion mass to minimum 15 solar masses. This exceeds the Tolman-Oppenheimer-Volkoff limit of 2.17 solar masses for neutron stars. X-ray spectroscopy shows emission temperatures of 10 million Kelvin, consistent with accretion disk dynamics at 30% light speed. By 1971, all alternative models are eliminated. The companion emits no electromagnetic radiation. Its mass exceeds all known stable configurations. The X-ray flux matches predictions for matter crossing an event horizon at the Schwarzschild radius calculated for 15 solar masses. The object meets all criteria for the singularity Einstein declared impossible. Hubble Space Telescope measures gas rotation at M87 galactic core. Orbital velocity is 550 kilometers per second at a distance of 60 light-years from center. The enclosed mass is 6.5 billion solar masses. The mass concentration radius is smaller than our solar system. No known stellar population or gas cloud can sustain this density without collapse past the Schwarzschild radius. April 10, 2019. The Event Horizon Telescope releases the M87 image. The photon ring diameter is 42 microsecons, equivalent to 40 billion kilometers at M87's distance. The Schwarzschild radius for 6.5 billion solar masses is calculated at 19 billion kilometers. The observed shadow includes the photon sphere at 1.5 times this radius, predicting a 38 billion kilometer shadow diameter. Observed value is 40 billion kilometers. The 5% deviation is within instrumental resolution limits and gravitational lensing models. September 14, 2015. LIGO detects gravitational wave event GW150914. Waveform analysis isolates 2 compact objects, 36 and 29 solar masses, with spin parameters and no electromagnetic emission. They merge. The final object has 62 solar masses. 3 solar masses convert to gravitational wave energy at 5.3 times 10 to the 47th watts peak luminosity. The ring-down frequency matches the fundamental quasi-normal mode for a Kerr black hole with mass 62 solar masses and dimensionless spin 0.69. Deviation from general relativity prediction is 0 within measurement uncertainty. The LIGO-Virgo-Cagra collaboration has confirmed 90 gravitational wave events as of 2024. 87 are classified as binary black hole mergers. Mass measurements range from 5.7 to 142 solar masses. Some objects exceed 50 solar masses, requiring formation mechanisms inconsistent with standard stellar evolution. Others show spin-orbit misalignment inconsistent with isolated binary formation, indicating dynamical capture in dense stellar clusters. The theoretical contradiction remains unresolved. General relativity predicts information crossing the event horizon is encoded at the singularity and permanently inaccessible. Quantum mechanics requires information conservation in all closed systems. No accepted framework reconciles these requirements. The singularity itself remains outside observational access and potentially outside predictive physics. Whether infinite curvature represents physical reality or a boundary condition for incomplete theory is undetermined. Einstein's 1915 equations predicted objects where space-time curvature diverges, where all geodesics terminate, where light cannot escape. He concluded the prediction was unphysical. Observational data from Cygnus X1, M87, and 90 gravitational wave events confirm the objects exist and operate as the equations specify. The Schwarzschild radius is measurable. The event horizon is detectable via its shadow. The equations were correct. The information paradox, the singularity's nature, and the quantum structure of event horizons remain open. If Einstein's equations correctly predicted black holes despite his rejection, what other exact solutions to general relativity describe phenomena currently dismissed as coordinate artifacts or mathematical curiosities?